Hello and welcome to yet another video where we will be discussing the solutions to the next contest that we had with Coding Ninjas. So in this contest also we had 4 questions, out of which 2 were easy, 1 was medium and 1 was difficult. So let's move forward and discuss the solutions to these questions. So this is our very first question. As you can see, the name of this question is Ninja and String Conversion. So let's try to deal with this question. This question says that a ninja has a string S of length n consisting of both lowercase and uppercase letters. He has to perform these tasks that if the letter is in lowercase, then replace it with the next letter. Example, replace A with B, B with C, and Z with A. Or if you call it Z, then Z with A. If the letter is in uppercase, then replace it with the previous letter. Example, B with A, C with B, and A with Z. So what this question is trying to tell us is that whenever we try to iterate over the string character wise, and whenever we encounter a character, first we will check whether the character is uppercase or lowercase. If the character is actually in uppercase, then in that case we have to move to a previous alphabet. For example, if the character is, let's say, C, then the previous alphabet to C is B, then it should be replaced by B. And similarly, whenever the character is in lowercase, then we have to replace this character from a lowercase, or we have to replace this character from the or with the next lowercase value. For example, if the character is, let's say, E, then we have to replace it with F, given that E is in lowercase. And we also have to deal with the condition that if the lowercase alphabet is Z or Z, then we have to move with A. That means we have to cyclically come back to A, and the same thing in the other direction when it is in uppercase. So let us go ahead and start writing code for it. So this is the given template or the boilerplate code that we have as of now. So let's try to go ahead and start writing code for it. So one thing that I will do is I will first of all convert this string into a character array. So I'll write char, and I'll write char array equals string to char array. Okay, so this will convert my string into a character based array. Now I'll start iterating over the string. So int I equals 0, I is less than n, and then I plus plus. Okay, now inside this loop, first I will start to check if the character is in uppercase or lowercase. So in Java, we have an internal function to do that. Okay, we have an internal function to do that. So here I will write character dot is uppercase, and here I will write char array I. Okay, which means that I'm trying to check if the char array I is actually a uppercase value or not. In case if this condition is true, then I will check for a base condition and I will see if char array at I, if it is equal to uppercase A. In case if it is equal to uppercase A, then it must be converted into Z. So then I will replace the value char array I equals Z, uppercase Z, like this, or Z, however you want to call it. Otherwise, we will just replace it with a previous character, right? So I'll write it like this, char array I minus equals 1. Okay, that means I'm trying to subtract the value of -1 from whatever ASCII value that is present inside this char array I. Otherwise, inside an else condition, I will write a something very similar. I'll paste it over here. If the character at array I, if the character at char array I is equal to Z, then it should be replaced with A. Otherwise, it will move in the forward direction like this. So now my char array is containing the characters in the right fashion that we want. Lastly, I will just convert this char array into a string, and I will write return new string with char array. Okay, let's try to run it. So running this code, it says 5 out of 5 test cases passed. That's great. Let's try to submit it. And upon submission, it says correct answer. So that is great. This was our very first question. Let's try to move towards the next question. Alright, so this is our next question, and it's called Planet Misery. So according to this question, it says Ninja has set out on a mission to explore planets in 2 separate solar systems. The first system contains n planets, while the second system contains m planets. The Ninja aims to visit as many planets as possible while following 2 specific rules. Ninja cannot visit the same planet more than once, and Ninja cannot visit 2 planets of the same solar system in a row as he finds it boring. Find the maximum number of planets Ninja can visit. Well, it's a very simple question. So I hope you're able to understand the question first. So we have 2 solar systems, and every solar system will contain some specific number of planets which is given to us as M and N. So the Ninja wants to visit the maximum number of planets inside both of these 2 solar systems, but the Ninja has to follow these 2 conditions. That is, Ninja cannot visit one planet more than once, and he cannot visit or she cannot visit 2 planets of the same solar system in a row because they find it boring. So that is a condition. Well, now we'll have to start thinking of a solution to this. Okay, now we will have to start thinking of a solution to this. So the idea around this is going to be like this. So if both the solar systems will contain the same number of planets, then they can immediately hop, like let's say 3 and 3. So they start from solar system 1, they move into the first planet of solar system and move into the second planet of solar system, like this. Let's say I'll take the example of 3 and 3. So let's say this is our first solar system, this is first solar system, and this is our second solar system. Let's say question mark, question mark, question mark. So each of these are planets. So each asterisk mark represents a planet of solar system 1, and each question mark represents a planet of solar system 2. So let's say they start from here, first this, then second this, then third this, and then this. So as you can see, whenever the number of planets is equal, then it's basically going to be the sum of both the numbers or multiplied by 2. But in case if the sum, or in case if the value is different, like this, then how do we understand? Okay, so we know now that whenever the value is equal to the same, whenever both the solar systems will contain the same value of or the same number of planets, that is when N and M are equal, then in that case the answer is going to be the sum of both the numbers, right? But if they both have different number of planets, then the Ninja may or may not be possibly be able to visit all the planets. Okay, so whenever the number of planets is going to be different, then if the Ninja will start to visit the planets from solar system with, let's say, fewer planets, that is this one, then the Ninja can visit twice the number of planets for which there are lesser planets. For example, let's say we start from here. So we start with this, then go here, then we come to this one, then go here, then we go with this one, and then go here. Okay, so as you can see, whenever the value or whenever the Ninja is starting from the planet which is lower in number, or whenever the Ninja is starting from the solar system which has lesser number of planets, even in that case, the maximum value or the maximum planets that they can visit is going to be twice the number of the planets which is present inside both of them. Okay, I should say twice the number of planets which is present inside the solar system with lesser number of planets. But if the Ninja starts with the solar system with larger number of planets, which is, let's say, in this case, then in that case Ninja can visit one planet at the end. So for example, let's say they start here, then they go here, then they start here, then they go here, then they start here, then they go here, and then they can come over here also. Okay, so what are we getting out of this? What we are getting out of this is that first we will calculate which one is smaller, we will multiply it with 2, and then we will add 1 to it. Because if we start with the planet, or if we start with the solar system with larger number of planets, only in that case we'll be able to maximize the number of planets that we can visit. So the maximum number of planets that we can visit in hopping both the solar systems will be 2 multiplied by the minimum of N and M. But because we are going to come back to the solar system with larger number of planets, so we will add 1 to it. And that is how we will be able to solve this problem. So let's write the code for this. We will come here and we will write if N equals to M, then just return M plus N. No complication, otherwise just return 2 multiplied by maths.minimum of N and M plus 1. Okay, this is going to be our answer. Let's try to run it. So we can see all the test cases are valid, and upon running it, we see compilation check right, optimal test case is running, and yep, we are able to see it is the correct answer. That is great. Let's move towards the next problem. So this is the third question, which goes on with the name of next one for sure. So let's try to read the question. It says, you are playing a game and summoning in the hopes of obtaining your favorite character. The chance of getting your favorite character in one summon is X%. You want to summon your favorite character twice because once just isn't enough. Of course. Thankfully, there is a pity system. If you do not get your favorite character in Y minus 1 consecutive summons, then you will get them on your Yth summon. Okay. Return the expected number of summons you need to obtain 2 of your favorite characters. Note if the expected number has a fractional part, you must return the smallest integer greater than the expected number. Okay, as there are no fractional summers. Okay, fine. So let's try to understand this question. So we have this example x equals 50 and y equals 2. So x equals 50 means that the probability is actually 50 for getting the character once in one summon, and y equals 2 means that in 2 summons, like at least every time in the second summon you will get the character. So this is possibly possible in 4 scenarios. For example, scenario number 1 is that you have to make 4 summons. Note that you have to get your favorite character 2 times. Okay, so let's say you're trying to get your favorite character. You did summon once and you did not get, so you did summon again. Because the value of y is equal to 2, in the second summon you will 100% get your character. Now you want to get it for the second time also. So in the third summon you called again and then you did not get, so therefore in the fourth summon you were able to get. So this is the first scenario. In the second scenario, in your first summons each time you were able to get your favorite character. In the third scenario, in one summon you got your character, but in the second summon you did not. So therefore in the third summon you got your second character also. So these are the only 3 possible scenarios that are there. Okay, so this is how the question is supposed to be. Now we have to solve this question. So solving this question will be a little bit tricky in my personal opinion, because it's involving mathematics and the concepts of probability. So let's try to understand how we will be able to do it. So we have a very clear vision that we will be able to obtain our favorite character by luck. When I say by luck, that means that we are not following the pity system. So we will be able to get our favorite character in first summon to y minus 1 summons, okay, through our luck. But if the pity system will trigger, then it is 100% sure that we will get our favorite character on the yth summon. So what is the probability of getting our favorite character in mth summon, given that m is less than y? Then in that case, as far as my mathematics is correct, then I think it should be something like this: x by 100 multiplied by 1 minus x by 100, 1 minus x by 100 raised to the power of m minus 1 for m is less than y. Okay, so this is the probability of getting the value of, or getting a favorite character whose probability of getting in one summon is equal to x, and this is the formula for getting them in m summons. Okay, so when the value of m is actually less than y. So this is what we have. So therefore, getting it on the yth summon will be equal to what? It is going to be the same thing, only it will be changed to y. Okay, so the probability of getting our favorite character on the yth summon will be equal to this thing. Let me just write it very clearly. This thing is for m, but this thing is for y. Oops, not here. But for y, it is going to be just this much: 1 minus x by 100 to the raised to the power of y minus 1. Okay, here when like on yth summon. So this is going to be the probability. Okay, so now this is of getting a character like independently, which means that when you want to get the character only once, but we, according to the question, we have to get the character 2 times. So the probability of these independent summons will remain with this formula only. But because we have to actually get two summons, or we have to get the favorite character 2 times, so our overall probability is going to be the combination of the number of summons. So if we summon our favorite character for the first time on the mth summon and for the second time on the kth summon, then the overall probability is a product of their individual probabilities. And this is how probabilities work. So we will take the individual probabilities of both the cases and we will multiply them both. So that will give us the probability. So now we can iterate through all the y square possible combinations, y square y, because we have to get it 2 times, find the probability, and subsequently we will find the expected number of summons. the expected value will be what? Will be equal to value multiplied by probability over all the possibilities. So we will be able to solve this question like that. Okay, let's try to move ahead and try to actually solve this question. So I'll start writing my code over here. I will write double, let's say probability. Let's say I should write it individual probability. So let's say independent probability. Independent prob in summon is equals to new double y. Okay, so this array is going to store the probability of independent summons, okay, or getting the favorite character in an independent summon, something like this. Okay, now I will write probability, sorry, independent prob in summon, which is this thing, at 0 should be equal to 1, just a base case scenario. Now I will start writing for int I is equals to 1, I is less than y, and I plus plus. Now I'll start populating this array. So this I will be equal to independent probability in summon I minus 1 multiplied by 100 minus x divided by 100. Basically, I'm just trying to create this formula. Okay, I'm just trying to create this formula. How? Let's say that when the value of m is actually equal to 1, when the value of m is actually equal to 1, then in that case, this thing will become 1, or 1 minus 1 will become 0. So this whole thing will become the same, right? This whole thing will become same. So right now, when the value of I is equal to 1, this will become 0. Sorry, this will become 0, which will become 1 over here. And then 1 multiplied by 100 minus x, 1 multiplied by 100 minus x by 100. So the same thing is here, 100 minus x by 100, right? It's the same thing which is written over here. All right, so using this formula, when the value of m is actually equal to 2, then in that case, we will just take the previous value and multiply it with this thing, right? So that is what I'm trying to write inside this formula. Mathematically, it's the same thing. All right, so now after this loop, what I will do is I will try to create my answer. So double, let's say estimated summons is equals to 0. Okay, now I'll start to loop through this condition. So for int I is equals to 0, I is less than y, and I plus plus, and then another for loop for int j is equals to 0, j is less than y, and j plus plus. Should write it like this, j plus plus. Now inside this condition, what I will write is double current combination probability is equals to, I know it's a very long name, but it's only fair. So the current combination's probability will be equal to the probability of at I, or getting it in the ith summon, and then probability of getting it in the jth summon, like this. Okay, after writing this, I will write if I is not equal to y minus 1, if I is not equal to y minus 1, then in that case, current combination probability is equal to, or let's say multiplied by x by 100.0. The reason why I'm writing 100.0 to represent the double value, or I can just also write 100d like this. Otherwise, I'll write another if condition. If j is also not equal to y minus 1, if j is also not equal to y minus 1, then in that case, the same thing is going to be there in the same way written. All right. So, yep, that's pretty much it. And let's move ahead. So now we'll have to populate the value of estimated summons. So after this if condition, I will write estimated summons is equals to, or plus equals to, I plus j plus 2 multiplied by the current combination probability, like this. Okay, so this will give us the total estimated summons. Now lastly, I'll get out of this for loop situation, and then I will write return typecasting into integer, and I'll write math.ceil estimated summons. Let's try to run this code. Run it. I know the variable names are very long, but it's only fair. Let me just submit it. So we can see that it's actually 100% correct. That's great. So this is how we can solve this problem as well. Now let's move towards the last question for this contest. Alright, so coming back to the last question for the contest, which says pile of chocolates game. Alright, this question says given n piles of chocolates, where the number of chocolates in each pile is denoted by an array A, there are two players, John and Ron, who will play a game on these n piles. In each turn, a player can either remove any number of chocolates from a non-empty pile or choose a pile that has k chocolates such that k is a multiple of 3 and replace that pile with x piles containing k by 3 chocolates each. The player who cannot remove any chocolate will be considered the loser. If both the players can play optimally, we need to determine the winner. Return 1 if John wins, otherwise return 0. Okay. All right. So it looks very similar to a very famous algorithm. So it's basically very similar to another problem, or it's basically very similar to another algorithm which is very famous in the world of programming. So let's first try to understand the example that is given to us, and then we will move towards that algorithm. So this example is the value of n is equal to 3 and the value of x is equal to 2 and the value of a, which is our array, is equal to 369. Cool. We have 3 piles and the players of chocolates and the numbers of chocolates are 3, 6 and 9, cool, respectively. John will start the game. Let's say he randomly removed 4 chocolates from the pile with n9 chocolates. That means he's targeting this one. So upon targeting this one, the array will become 3, 6 and 5. Okay, cool. Then then it's turn for Ron. So Ron chooses the pile with 3 chocolates and replaces it with x by 2. X equals 2 piles containing 3 by 3, that is equal to 1 chocolate. So according to the question, it says that they can choose a pile that consists of k chocolates such that k is a multiple of 3 and replace that pile with x piles containing k by 3 chocolates each. So he has chosen this particular pile when the first one that is containing 3 chocolates. When divided by 3 it becomes 1, and because the value of x is equal to 2, so we will add 2 extra piles of chocolates like this, which will contain 3 by 3 chocolates each, that is 1 chocolate each. Then John will go next. He removes 1 chocolate from the pile with 6 chocolates and the array becomes 1155. It can be shown that if the game continues with the optimal play, John will always win. Well, like I said, it is very similar to another problem. It is called Sprague-Grundy theorem. Let me just write the name for you. I just remembered. Let me just write it over here for you. It's called Sprague, or I don't know how it's pronounced. Is it pronounced Sprague or something? I don't know. So Sprague-Grundy or Grundy theorem. Okay, it is also popularly known as NIM. Okay, it is also popularly known as NIM. So basically, this theorem is about it basically talks about a so-called impartial two-player game, that is those in which the available moves and winning and losing depends only on the state of the game, just like in this case. In other words, the only difference between the two players is that one of them is going to move first. Like in this case also, John is playing before Ron. We are going to assume that the game has a perfect, like everybody knows everything, okay? So in this particular theorem, there is this game called NIM. So NIM is a game. Inside NIM, what happens is that there is a set of rules. So any perfect information impartial two-player game can be reduced to the game of NIM, just like in this case. So we have all the information that is given to us, and it is also a two-player game where one player is going to play before the other. Okay, so in this game what happens that there are going to be several piles. According to the description of NIM game, there are several piles just like in this case, and each of these piles will contain multiple stones, whereas in this case we have chocolates. In a move, that is when a player is making their own move, they can take any number of stones from any one of the piles, just like the players here are able to take the chocolates from a pile and throw them away. That means reduce it, just like here also they are actually removing it, right? So if a player will lose if they cannot make a move, which happens when all the piles are empty, which is exactly what is happening over here also. So it says the player who cannot remove any chocolate will be considered the loser. Okay, so it's the same kind of question. Okay, it's the same kind of question. All right. So this particular question has many things that are there, but then there is a very simple situation that needs to be considered. Okay, so according to this theorem that we have, Sprague and Grundy theorem, it says that the current player, that is whoever is playing, they have a winning strategy only and only if the XOR sum of all the piles that is present becomes non-zero. So if we try to calculate the XOR of all the values present in this array and add them up, then we will check whether the value is 0 or not. If the value is 0, then the player can actually not win. But if it's non-zero, then the player may actually be able to win. So something like that is what we are going to do. So let's move with our first step. So let's try to calculate the XOR values of all of them. Okay, so that is what we will start with. So we will write the code over here. Suppose I write int result is equals to 0, and then I will write a for loop. So for int I is equals to 0, I less than n, and then I plus plus like this. And then here I will write result is XOR like basically added, basically I'm calculating the XOR of all the numbers. Okay, so I'll write AI, something like this. Okay, so I'm XORing all the numbers with each other, and the XORing the result with the current value, something like that. And then I will check if, or I'll just write a ternary operation, if result is not equal to 0. If it is not equal to 0, then in that case John can win, that is 1, otherwise it's going to be 0. Alright, so that's how. So this is all about Sprague-Grundy theorem. If you are not familiar with this, you can just give it an internet search and you will get the right answer. And NIM is actually a game. So this is exactly the NIM game only. The question that we have, it is a NIM game only. And I'm just following the Sprague-Grundy theorem, which says that in a situation like this, just do a XOR operation of all the values that are present in the array, and just continuously do the XOR, and whatever answer you get, check whether the answer is actually 0 or not. If the answer is 0, then the player may not be able to win. But if the answer is non-zero, then the player will win. So that is exactly what I've done. Let's run this. Upon running it, we see all the 5 test cases are clear. Upon running it, submitting it, we see that all the test cases are also getting passed. So that's great. And this is how we come up with the solutions to all the problems that were present inside this contest. So that's pretty much it from my side in this video, and I will see you in the next contest video. Thank you.